Okay, let's give you guys some more practice. So find the Maclaurin series for this function. So here you've got one block multiplying this block. So this is e to the power of x squared. So press pause and have a go. Okay, so to do this, we should be making use of this. So to do this, we should be making use of this. So if you look at this, this is e to the power of x. But the thing is, if you look at our function, let's just concentrate on this block as opposed to this one. So here you've got e to the power of x squared. So what that means is you've got to put x squared into here. You've got to put x squared into here. So the series will become 1 plus x squared, and then this will be x squared, and so on, all the way to infinity. What it means is when you have x squared in here, your series will become this x squared. So now, so this whole block here can be represented by this series. Well, let's tidy up this series. Here you've got x squared to the power of n. So this times this, that will then become this. So what that means is, what it means is, here you've got one block multiplying another block. Well, this block here is this block here. So our function would be x squared times this series. So our function would be x squared times this series. So when you look at this series, what you've got here is x squared, and the series, this series would be this, will be something plus something plus something plus something, and so on. So when you multiply this out, this will then become x squared times something plus x squared times something plus x. The point I'm trying to make is that you can actually push the x squared into here. So you can push the x squared into here, because when you multiply this out, this will attach itself to this x squared. This thing here will attach itself to x squared, and so on. You can actually push this into here. So this whole thing here will then become this. So now same base. So you can just get this, add this. So it will be this, add this. So this will be your series. So now we need to check where the series is valid. So if you go back to here, you see for this one here, the series would be valid when the absolute is less than infinity. So in our case, remember, in our case we've got x squared. In our case we've got x squared. So if you look at this, absolute value of x, but in our case it's x squared. So in our case it will be absolute value of x squared less than infinity, which will imply that it will be valid for all values of x if you interpret this. Okay.